Okay, this is part B, or the second video for 5-2 graphing and slope-intercept form. So, the last few examples here. In this example number 1, they want us to write an equation of the line with the given slope and y-intercept. Now, first thing you need to remember is that slope-intercept form is y equals mx plus b, and this is where the m is your slope and the b is your y-intercept. So if in example A they give you your slope, they're simply telling you your m is 8 and your y-intercept is -3, they're telling you your b is -3. You just write your answer. Your slope-intercept form equation is y equals 8x minus 3. Done. Same thing for number 2, or letter B here. If the slope is -1, they're simply telling you m is -1. And if the y-intercept is -7, they're telling you your b is -7. So again, you just write your answer. Y equals m is -1 times x plus b. It's just in this case the plus b is a -7, so you're done. There is your slope-intercept form. If they give you the graph, they really are giving you the same thing. They are going to, in each of these graphs, tell you what the m is and what the b is for each of these graphs. You just have to look and figure out a little bit on your own what each of these numbers are. Well, in example A here, you can look for the y-intercept, and you can see that the y-intercept, or the point where the graph crosses the y-axis, is right here. Well, that y-intercept is 0, -1, so we know our b is -1. And then to figure out your slope, you just count your rise and run. In this case, I rose 1, 2, 3, and I ran 1, so my slope is going to be 3 over 1, which we know is just 3, so my answer is y equals 3x minus 1. Problem 2, again, you look, I see that the graph started right there. My y-intercept was 2, and again, for my slope, I'm just going to count. In this case, I went down 1, 2, 3, so that's a -3, and right 2, so my slope is -3 over 2, making my equation y equals -3/2 x plus 2. And last graph here, again, I look for my y-intercept first, and that would be right here at 0. And then my slope, and you can pick any of the 2 points. I'm going to pick this point here. So I rose 3, that's a +3, and then I went left 2, that's a -2. So my slope is -3/2. So my equation is going to be y equals -3/2 x plus 0, and we know that if we have a plus 0, we don't need to write it, right? So our answer is just y equals -3/2 x. So those should have hopefully been pretty easy. Just simply find your slope and your y-intercept and plug them into this equation for m and b. Okay, the last example of this section is story problem. The story problem is also going to be talking about slope-intercept form. So again, I'm going to write over here y equals mx plus b, just to remind me what equation I'm using. I'm also going to remember that m is my slope and b is my y-intercept. Now, another thing you might want to think about when you're doing story problems in slope-intercept form is that since you always start your graph with the y-intercept is also, I kind of think of it in my head as my starting point, or where I'm starting at. And then the slope, since slope is rise over run, slope is kind of like how I move. I'm going to move based on rise and run on my slope. And you can apply these two kind of thoughts into our story problem. The first equation says you rent a bike for $15 plus $2 per hour. Well, if I use these words that I've talked about over here, you might say, okay, well, what am I starting at? Well, I'm starting at $15 because I have to pay $15 no matter what. So in my y equals mx plus b equation, 15 is going to be my b because that's the starting amount. I'm starting at paying $15. That's a guarantee. And then you might say, well, if that's the case, then the plus $2 per hour is how I move. I'm going to move up $2, or I'm going to pay $2 more for every hour I have the bike. So I'm going to go up $2, up or pay more, so I'm thinking of it as a positive 2 is how I move. My slope is going to be 2. Now, you could finish this equation out by simply saying, okay, my equation is y equals 2x plus 15, but I like to use different variables because we're talking about a story problem. So I'm going to say in this story that C, representing cost, the cost is going to equal $2 times H representing hours, $2 for every hour I rent the bike, plus $15. And this here then is my slope-intercept form equation of that story. Okay? Let's look at B then. A candle is 6 inches tall and burns at a rate of 1/2 inch per hour. Again, where does the candle start? Well, the candle starts at 6 inches tall. So again, in my thought process, the 6 inches is going to represent my B. I'm going to write this, well, I'll just write it right here. So I have I'm going to have plus 6 for my last part. Again, that's going to be my B. Now I think, how does it move, or what's happening to the candle? Well, the candle is burning, and here's a key word, burn. The candle burns at a rate of 1/2 inch per hour. Well, if the candle's burning, it's going down, so I'm going to put a minus. Let's get this out of the way here. I'm going to put a minus 1/2 x. But again, since I have a story problem, I don't like the variable x because x is just generic. I'm going to use the variable h again because it's going down by 1/2 inch every hour. And then instead of y, I'm going to use t for how tall the candle is. The candle is, how tall the candle is going to be, it starts at 6 inches tall and it goes down 1/2 inch every hour. So there's your equation, t equals negative 1/2 h plus 6. Again, negative 1/2 because it's going down. Alright, and finally the total cost of gasoline is $1.80 times the number of gallons G. Well, again, that one's just going to be total cost is going to equal $1.80 times the number of gallons. Where is our starting point in this problem? Well, it's starting at 0. If you don't buy any gallons of gasoline, you don't pay any money. So our starting point is actually 0. So our y-intercept is 0. And if you're buying gas, it's $1.80 times the number of gallons. Now, obviously, this is an old equation, an old problem I found in a book. Gasoline has not been $1.80 for a long time. This should be more like $3.80. But for the sake of the problem, we're just going to leave it as $1.80. So if you have to graph this problem, which since the graph's included here, I'm assuming we're going to graph it. I'm going to use my timeline like this, and along the bottom here, again, think of this as your y and this as your x. So along the bottom here, along my x-axis, I'm going to have gallons. I'm just going to do 1 gallon, 2 gallons, 3 gallons, 4 gallons, 5 gallons, so on and so forth. And along this side, you're going to have money or price. So this is gallons, and this over here is going to be dollars. And I'm going to label my dollars. I'm going to do the same, since I'm going to count by twos, since we did such an old version. 2, 4, 6, 8, 10, 12. And again, if you're going to graph this, you're going to say, well, I'm going to start this at 0, because if I buy 0 gallons of gasoline, it's going to cost me $0. Well, what happens if I put 1 in for G? Well, 1 gallon of gasoline is going to cost me $1.80. Well, what if gasoline is 2? Well, now I have $1.80 times 2, which gives me $3.60. So at 2 gallons, I'm up to $3.60, which will be right in there. And then if I come back and say, okay, well, what if I have 3 gallons of gasoline? And that's going to be $5.40. So I end up with $5.40. So 3 gallons cost me $5.40, somewhere in there. And you see this graph is going to look something like this. So there you have it. There's the rest of 5-2 graphing and slope-intercept form.